Hello, everyone. My name is Forough Shahab. I am a PhD student at KTH, and today I'm going to present our management system for dynamically meeting performance objective on a service mesh. This work is a joint work which is done with Kim Hammer and Professor Rolf Stadler. In this work, our focus is on a microservice-based application running on a service mesh. We model the service mesh as a directed graph, and each service on this service mesh is considered as a contiguous subgraph, and we associate different metrics such as end-to-end quality of service metric to each service. The goal is to meet end-to-end management objectives defined for this application on the service mesh by dynamically adjusting the control parameters in this system. So for this purpose, we use reinforcement learning, and when we try to apply reinforcement learning, we face some challenges, for instance, long training time. To address this challenge, we develop our framework, which is presented in this figure, and we detailed actually in our previous publications. So as we can see in this figure, this framework includes mainly two parts. The first part is the testbed or the target system that we have, which the services are running on this part. And the second part is the simulator, which is based on the system model learned from the real data collected from the testbed. So to learn the control policy or close to optimal control policy, we have to take 7 steps mainly in our framework. These steps including to define the management objective, to specify the control actions that we can change or take in our system. Moreover, we have to define the reinforcement learning model and scenarios. Then we run the scenarios on our target system and collect the data from the target system, and then use this collected data and learn the system model. Using the system model, we set up our simulator, and on the simulator, we train the agent, the reinforcement learning agent, to learn the control policy or the optimal control policy. And finally, and most importantly, we evaluate these learned policies on the target system. And the target system actually is shown in this figure. It includes different layers. So for instance, OS layer, the orchestration and service mesh layer, and application layer. And we have this management system which run the agent and check the performance of the agent. In general, what we are going to demonstrate now and in this work includes different parts. In the first part, we show the evolution of system metrics for the given management objective and the specified load pattern, and how the system reacts towards the agent running on the system or the pre-trained agent. So here actually is our management system. The first page actually is the introduction page, which shows the directed graph of our application running on the service mesh. This application includes 5 microservice nodes with different functionalities. Moreover, in the right side, you can see the management objectives defined in our system. For instance, the management objective 1 is maximizing overall throughput while we are meeting the delay constraint for each service simultaneously. The second page, which is the main page of our demonstration, includes mainly 2 parts. The first part, which is which is shown in the left side, shows the performance of the system and how the system reacts toward the action that agent takes. In the right side, we show the control parameters and how these control parameters change when the agent takes the action. So in the left side, we can specify which management objective we are interested to apply in our system and what load pattern we like to apply. And what we can see in the upper window, we can see the offered load to the system, which clients send, and also the carried load that system can reply. And here the carried load and offered load are equal most of the cases, unless in the cases that agent change the admission control parameter or block rate parameter. For instance, you can see from time step 41 to 49, when this the blocking rate changes, we can see that the carried load is lower than the offered load, which we can see for this service 2, this parameter is changed. Below, we can see how the response time changed, and we can compare it with the threshold defined in our management objectives. And there is a point here which we like to mention. As we know, to meet this management objective, we map the management objective to the reward function in our reinforcement learning model. And we consider these constraints are soft constraints and define them in a soft way in our reinforcement learning function. The last window in the left side, we show the performance of the agent. So we show it in NR values or normalized reward. The normalized reward is actually the ratio of the reward that agent obtained to the reward that it could obtain. I mean, the optimal reward that it could obtain with that specific system model which we have or defined. The highest value for NR is 1, the lowest is 0, and here we can see that in most of the cases, it is higher than 0.5. In the right side, we can see the actions that agents take in our system. So in the top part, we can specify which service we want to observe, and the current values of the parameter is shown in this red color. Block rate and also routing rates. And also below we can see the window which shows the actions that agent take for these specified time steps and also the routing rate we have. This is actually the thing that we wanted to show as our management system. Thank you for your attention.